Hi everyone, this is Soumyadi Paul, a mentor at CodeKerdos and a software developer at Amazon. And this is day 15 of our DSA series. And today we'll be seeing what is bubble sort. In the last few videos, we saw what are arrays, and then we did a few questions learning and understanding the concept of two pointers in arrays. Now today we'll be learning what is bubble sort. Okay, so obviously if we have an array, we want to sort it. Sorting means storing the elements in an increasing or decreasing order. For this video, we will always be talking about increasing order. Okay, sorting means increasing order of elements in an array. So suppose we have a randomized array, say something like 19304545. 1, 9, 3, 0, 4 and 5. Okay, if I sort this array, this becomes something like this. 0, 1, 3, 4, 5, 9. Okay, so this is what we want to do. We are given an array and we want to learn an algorithm that sorts this array. Okay, which sorts this array. Now as a software developer, you need to primarily know 5 sorting algorithms. 5 sorting algorithms. Okay. 5 sorting algorithms. What are these 5 sorting algorithms? Well, not 5, sorry, my bad. Actually 6. Okay, 6 sorting algorithms. So first one is bubble sort. Okay. Second one is selection sort. Then the third one is insertion sort. Then we have merge sort. Then we have quick sort. And then at last we have heap sort. Okay. So these are the 6 different sorting algorithms that every developer should know. The first 3 are quite simple and a bit slower, and they have a time complexity of big O of n square. The next 3 are a bit faster and better sorting algorithms and have a time complexity of big O of n log n. Okay. So in our day-to-day life as developers, for any use case, we will always be using mostly merge sort or quick sort. The Java's internal sorting algorithm is also built on quick sort. But even though we won't be using bubble sort, selection sort and insertion sort, as good developers, we should know what bubble sort is, what selection sort is, what insertion sort is. Okay, so in today's video, we will be learning what bubble sort is. Okay, now very simple. What we do in bubble sort is that we keep on swapping alternate elements. Okay, what we do is in bubble sort, we keep on swapping alternate elements. Okay, alternate elements. Okay, in a way to push the larger element to the right. Okay, so what we do is, suppose this is my initial array. This is my initial array. Here I'll see, oh, 1, 9. Okay, let me have this array again. Okay, let me draw this array again. 1, 9, 3, 0, 4, 5. 3, 0, 4, 5. Okay. Okay. Now we'll first see this pair. Should we swap this? We will only swap if we have the smaller element on the right and the larger on the left. But here we already have the smaller element on the left and the larger on the right. Okay, so we will be swap if larger element is on the left. Okay, larger element is on the left. Okay. Now here larger is 9, which is on the right, so I won't swap. Next I will see this pair, 9 and 3. Larger element is 9, which is on the left, so I will swap them. So let me swap them. Okay. So here comes 3, here comes 9. Then I'll again compare these two. Larger element is 9, which is on the left. So I will again swap them. So here I'll have 0, here I'll have 9. Then I'll again compare them. Larger element is 9, which is on the left. So I'll again swap them. Here I'll have 9, here I'll have 4. Here I'll have 9 and here I'll have 4. Again I'll compare them, and the larger element 9 is on the left. So I'll again swap them. So here I'll have 5 and here 9. So my array becomes something like this. 1 3 0 4 5 9. Okay, it still isn't sorted, but what did it guarantee us? It guarantees that the largest element is on the rightmost position. Okay, this is what it guarantees, that the largest element is on the rightmost position. Okay, so if by doing this process once, I can guarantee that the largest element will come to the right, because I'm continuously swapping and I'm pushing the largest element to the right, isn't it? 9 got pushed from here to all the way here. So if I do this process once, I can assure that the largest element will move to the rightmost position. So then I can say that the largest element is exactly what it's supposed to be, and the remaining array is not sorted. So now I can again do the same process on this remaining array. Okay, I can again do the same process on this remaining array. Is 1 3 I'll compare 1 3, which is larger. 3 is larger, it is on the right, so I won't do anything. 3 0, which is larger. 3 is larger, so I need to swap, because 3 is larger and it is on the left, so I need to swap. Then compare 3 and 4. 4 is larger and it is on the right, so correct, I don't need to swap anything. Then I'll compare these two. 4 and 5. 5 is larger, which is on the right. Again correct, I don't need to swap anything. So here in this second round, in this second iteration, I just swapped 0 and 3. So my array became something like this. 1 0 3 4 5 9. Now when I did this process second time till here, I can be assured that the second largest element was pushed to the second largest position. So now till this it is sorted, and till this it is unsorted. Okay, again I need to do the same thing. Compare. 1 is larger and it is on the left, so I need to swap it. So here comes 0, here comes 1. Then I'll compare them. 3 is larger and on the right, so I don't need to swap anything. Then I'll compare them. 4 is larger and it is on the right. I don't need to compare anything. I don't need to swap anything. So again my array comes this. 0 1 3 4 5 9. Now this portion is sorted. This portion is unsorted. Now I know this even unsorted position got sorted, but that was by mistake. That was by chance. Our algorithm will still run. I'll compare them. 1 is greater and it is on the right. Great, I don't need to compare anything. I'll compare them. 3 is greater and 3 is on the right. Great, I again don't need to swap anything. Then I'll come here and I can say this is my array. 0 1 3 4 5 9. Now I did this process for 4 times, so I can say that the fourth largest, which is 3, is on the fourth last position. Now this is sorted and this is unsorted. Okay, again I'll compare this. 1 is larger and 1 is to the right, so I don't need to swap anything. So my array now becomes this. And I can say this is sorted and this is unsorted. But when it is just one element, that automatically is sorted. Okay. So this is the logic. This is the algorithm of bubble sort. Okay. We just need to keep on swapping them. That's it. We just need to keep on swapping them. Okay. So let us code this. Suppose this is my array. Okay. This is my array. And what I'll do is I'll have a bubble sort function. It'll take an array and it will sort it. Okay. And here I'll call bubble sort. I'll pass the array, and then after I have called bubble sort on it, I'll iterate over the array and I'll print this array so as to make sure that my array got sorted correctly or not. And if you remember that in this process, swapping was a major component. We had to swap multiple times. Okay. So as good programmers, as good developers, we should always follow good programming standards. So if I have to do something multiple times, what I'll do is, and if something is very compact and that something that can be reusable, so I write it inside a separate function. So I'll make a separate function. I'll say public static void swap. It'll take an array, it'll take A, it'll take B, and it'll swap both indices A and B. So int temp is ARR of A, ARR of B is ARR of A, and ARR of B is temp. That's it, done. Okay. Now, if I just, in this bubble sort, I'll write the array, I'll write the algorithm. So what did we do first? We iterated over this entire array and checked that if the right element is smaller and the left element is larger, then I need to swap them. Okay. So here what I'll do is I'll simply iterate over this array. Okay. I'll go till the second last element. Why? Because I need to compare every element with its next element. So if I go to the last element, then I won't have anything for it to compare with, and it will give me array index out of bounds exception. So I will go till second last element so that I can do this. If ARR of I is less than ARR of I plus 1. Okay. If this is the case, that means the left is smaller, right is larger. If right is larger, great, things are good. I can continue to the next. I can just continue. Okay. But else, if left is larger, right is smaller, then I need to swap them. Okay, I need to swap them. I and I plus 1. Okay, that's it. So if I do this thing once, I will push my largest element to the right. So I need to do this multiple times. Okay, I need to do this exact thing multiple times. So I'll also run another for loop which will go from from 0 till last, and then I'll write this code, and here instead of I, I'll say J. Okay, great. Okay. And what I need to do is, okay. So now what I need to do is, you see, also one more thing. It is not necessary for me to iterate till the very end. Why? Let me do this. Okay, that's it. So if I now run my code, some error, in which line? Line number, okay, in line number 6, okay, in line number 16 when I'm calling this swap, okay, sorry, yeah, here also it should be J, that's why. Okay, you see, now it is working perfectly fine. But okay, some little mistake. What is that mistake? Okay, now you see the problem is that here, whenever you get a problem, what you should always do is you should always quickly dry run your code and see what is the mistake. What is it happening? In the very first iteration, my inner loop is going what? My inner loop is going from 0 till the second last. Okay, till the second last. Okay. Now, if this is happening, then okay, what I need to do is I need to do something like this. I'll start from here, -2. I'll say, yeah, this is a better way of writing this code. Okay, minus minus, and here I'll go till I equal to I. Okay, yes. Okay, still some mistake. So we'll try to figure this out. Don't worry. Okay, so let us try run this code once. Okay, suppose I have this array 1 and 3 0 4 5. Now what I'll do is I am doing this add.length -2, I greater than equal to 0, I minus minus. So I will be what? This is my array. I is what? 0 1 2 3 4 5, and length -1 will be, length -2 will be 4. Okay, so I is this, I is this. Okay, so now I am going from 0 to I, and if this is true, then continue, but else I am swapping them. Okay, I am swapping them. This is what I am doing. Okay, so now what I need to do is just a second. Temp is error A, error A is, sorry, error B, my bad. This was the mistake here. This was the mistake here. Oh, okay. Sorry, error A is error B and error B is temp. This was the mistake. Yes, now it is working perfectly fine. See, 0 1 3 4 5 9. Okay. So it quickly struck me that there must be some mistake in swap. Okay. So what is the issue? How is this code working here? First, I is length -2. That means I is pointing here. I is this 4. Okay. I is pointing here, here, isn't it? Now, my j is going from 0 till I. J will go from here till here, and it will do this comparison, this, and this. So it is doing all the comparisons. It is doing all the comparisons. So when I is length -2, then this is doing all the comparisons and moving the largest element to the rightmost position. The next iteration of I, and I will be 3. When I is 3, then I am going from 0 to I, means now from 0 to 3. So I am doing this comparison, this. Now I am not doing the last comparison. Okay, now I am not doing the last comparison. So this j inner loop of 0 till I is helping me, stopping me from doing the last comparison, or comparisons on the sorted portion of the array. Okay, so this is how your bubble sort code works. Very simple, just small. Or you can write it even smaller. You can just say, you don't need to write continue and all. Okay, you can just say, if this is greater, then I'll do this, and if you run, it is working perfectly fine. Okay, so you see, such a small code. Okay, just 4 lines here, just 4 lines code, and here 3 lines of swapping. Okay, so that's it about bubble sort. In the next videos, we'll learn about selection sort and insertion sort. And if you're having doubts, if you're not able to understand this, or if you want to learn personally from mentors who are working at Amazon, Google, Microsoft, etc., and want to deep dive into more difficult concepts and topics, then do join CodeKerdos. Okay, and I'll see you all in the next video.